back to 380. This is going to be hopefully a little speedier. It's not my first attempt, or third or fourth. This is wherever we are. Let's just save to get started. Gonna pick up a name from somewhere else. So if I open up the location, I can see my tree, go into somewhere where I've got a name I would like to use. Let's do number 6. Nice. Go back to where I want to be and save. Previously I've made some 2 gear shafts, pinion low gear and gear, big gear. Just insert these into the current design. And this is our first one that will just overlap the origin. So the origin of the component, the pinion will sit at the origin of our part. Say okay. Make sure it's grounded. Sorry, I forgot to turn on the app here. Let me just start it up. The goal here is to build a housing around 2 shafts. So we'll put in our second here. I know that the distance, the pitch distance, or the rolling distance, or whatever you want to call it, is 90. So just pull on my, in our case here, up through the positive Y, type in 90, ground apparent, say okay. Everyone's good, except we can pull these. So next and last step for these guys is to go ahead and rigid group them, include the child, and we can't pull it. This will save us from accidentally pulling something. Perfect. I'm going to save this just to make a point here. I'm going to call this shafts placed. This will trigger a version to be made and a good start point. CV2. Oh, there it is. There it is. Shafts placed. We'll close this down for now, the data panel. Now we want to make a housing around this. The housing has to hold the bearings hold the shaft holds the gears. So we've got an input shaft, usually an output shaft. This is not ultra realistic, they're very close, quite small. So we're going to deal with the tightness of this as well. So again, don't get too focused on this being the only way to do this housing. There's lots of different ways. We're just going to be making a point here. If I line up on this top front corner, we can have a look at the bearings. They're the same size on the outside. 31. However, we see the widths are slightly different. I've colored these components to my liking. I've made both of these bearings, which are from SKF, the same color based on width, and they have a different bore as well. So these are all modeled correctly by SKF. If we shift to wireframe, we can see the gears are from KHK, are all metric, so everything's looking okay. The goal for you guys here is to put a housing around this that makes sense, a rational housing. Excuse me. Let's have a look at the right thing. Let's have a look at our guide here. This is Orlov, Volume 2, Table 1, Figure 14, right up here. It's quite small. Sorry, I'm drinking tea here. Made so many videos, I'm losing my voice. The goal is to make this part, the housing, notice the gaps. And also the assembly motion, there's a mid motion here. So we've got bearings mounted, you'll see this ring. And the gears, in our case just one gear, will be dropped in from above, so we need a top cap. And the shaft with an attached bearing is pushed in from the side. This is feasible. For us, we are going to model the caps. We're not going to get carried away with any detailing around the cap. So in previous videos I made gaskets. We're going to skip that. We're also not going to fasten the caps, which causes no end of problems. We will try fastening the top cap, the housing cap, down though, which is not shown here. We also have a reference with SKF showing how bearings should be mounted, and notice the housing is lined up on the inside of the bearing for now. Also the gap around the ring and a gasket here. Again, for us in this video, we'll skip the gasket. My goal is going to be to keep the housing as bodies inside the larger component and only make the components right at the end. So that's the plan. So how do we get started? If we look again once quickly, we see that our housing is largely controlled by bearings and this ring. And in the Orlov, again, the bearing is coming in and is going to sit in the housing. So we need to be aware of various things. So we're going to map the housing based on the components, kind of similar to how we were doing shafts. Just going to move this here. So let's get started. First, we're going to need an inspection probably. Section analysis, just so we can see through the parts. See the balls modeled in the bearings. The shafts are solid. There's a key hidden up in the assembly further. So that's fine. Turn that off and on. Let's have that making a sketch. First thing I'm going to do is try and place something in a sketch so we can control our size of housing. So let's begin with a sketch on, say, the XY plane. Nothing happens because just make a sketch. If you click slice, it'll slice, similar to an analysis. But if you toggle it while it's upside down, you can slice the other way. Nice. One thing I'm interested in is where the bearings are. Let's go ahead and do a series of intersections or projections. I prefer using an intersection. I've added it to the sketch shortcut. How do you do that? You'll notice if it's not on there, you can add it at the end. And if you're careful and patient, you can grab it and drag it. So I've got a point, change parameters, intersect. It's too easy to pick edges and lines, so let's select, filter, turn off everything but the phases. Get all those edges. If you're careful, you don't have to move it too much. There we go. Let's hide those two guys for a second. Project solid lines. Let's select all and turn it to construction, or X on the keyboard. Then we want to accidentally get geometry caused by that. Finish the sketch. I'm going to call that the layout. It's a bunch of, like a speckling of right up top. We have a bunch of part targets in a way right now, so we're going to continue on with this. Sorry, moving stuff in my office here. Okay, so losing my voice. Get sick. COVID. Okay, so let's see here. I'm going to use these guides to build our extrusion. I'm going to create a new sketch. This is outrageous for Colin. Pick the correct plane if I can. So I'm going to be after my ZY, YZ. Say okay. Hold on here. Am I on the right thing? Just redefining, just in case I got the wrong one, ZY. YZ. And go ahead here and start getting stuff sorted out. I want to begin with the kind of general shape here. So, oh, that's not right. Start up the sketch. So we want to attach the floor. So my plan is generally a fairly boring shape, kind of like a rounded rectangle. Oh. Notice I'm all over the place here. I'm going to do things on purpose, so horizontal, vertical, and tangencies. The question is, where do we want to place things? Let's have a look here. We have the housing extending quite a bit above the gear and quite a bit below the larger gear, that is, not the pinion. So we're going to try and stick to that. So let's just pull that into kind of a shape. And let's make sure everything's fairly kosher. We're going to have a high cap, so maybe I want to see if we can grab that. Going to try and keep these fairly small. It's fighting me. Hold on. Pull this up. Oh, that's why it's fighting. It's stuck. So I accidentally pulled it onto something. Auto projected there. If you want, you can just delete that. I'll have to watch out for that. So there's our shape. Now let's start dimensioning. Where do we want the dimension from? The origin, probably. 95, let's go for 90. Now, I do have to be a little careful here. I want this to be symmetrical. So I'm going to try and fit this in. I would like this line to be symmetrical. Easy way to do that is to project something that gives me the other the other center mark. So let's try projecting something. Don't want to get the end because it's not going to give me a full circle. How about this piece of the shaft? Doesn't really matter which one I use. So let's go for this edge here. And might not be such a bad idea to do the same for the other one. There we go. So that can stand in for our two parts. Gives us two origins. Easy way to do that, well, there's various ways to do this. We can actually just draw a line to the middle from both. Make them equal. Maybe even make them construction so they don't get in the way. And that gives us a nice way of controlling our spot. Let's have another look. Not too worried about the small one, it's the big one. So let's have keep that one on. So because we have symmetry on, we can dimension from the origin to the whatever one we want. Let's go with 70. And then up, I've got 90 here. Would make sense to almost do the same. And then all that's left is to figure out how big this fillet is. So let's keep the symmetry going. And because my dimensions are largely on the left, let's stick with that. Let's say 40 for now. We're going to end up with a split. I'm going to map that in already, actually. So let's just attach it directly across. Right now it's construction. That's fine. Notice even though if I go beyond the fillet, that's fine. It does stay correct. So to me, I don't really see any problem with the top of the bearing sticking out a little bit, or the gear, sorry. So let's kind of get it about right. Say 50. Now we have a little bit of danger here because that edge is right on the start of the fillet. It may not be a big deal, but let's just decrease it a little bit. So that's my plan for the shape of the housing. Where do we go from? We're going to do an extrusion here. So this might be the inside of my housing, the void. So let's figure out where we're going to go from here. So look at SKF. We have the housing lined up on the bearing inside face. Fine. So let's do that. Now, let's do a prototype and then we'll come back and tidy it up a bit here. So extrude first. This thing's going to get in the way. So hold up before we do that. Can't do that yet. Edit sketch. Going to turn it back to construction, that part line. Just get the whole thing at once. Easier. While we're at it, sorry, I was going to do this later. Notice that we've got a hole here. So in the region, let's edit that sketch again. This one is also construction. There we go. But we already know the size of the bearings are all the same. So let's project our actual bearing size on here as well while we're at it. So let's project again. I'm going to pick this whole face on both. What does that give us? Right, there's our bearing. So we have a region which we can extrude and we won't get interface with the bearings, which is good. So E, this way. Now we want to go from the bearings, so we're not going to start from the profile plane, we're going to start from an object. It's a little hard to see here. So if I press Apple or Command or Control, you get a bit of, turn off the preview. So I want to start from the inside of the bearing. So I know where I am, let's go to home. So I'm going to pick that guy first. So that looks fine. And I'm going to go to the opposite side, which is over here. So not a distance, but to an object again. This should have the bearings sticking out completely. Let's turn everything on again. It's kind of good. Now I'm going to make a wall thickness here. So let's go with 5 and then try a shell after I drink some more tea. So first shell, no, let's do the nominal wall thickness. So let's do a search, param, nominal wall thickness standard. Let's make it 5. Shell, shell, shell. Pick the whole body. It's easy to pick in the tree or in the browser. And let's go outside. NWT. It's acting correctly. You can see it eating a bit of the bearings. That's okay. Turn on our analysis. Now, ideally, the housing goes right through the. We can see we have a small area here. Ideally, though, the shell goes right through the ball in the bearing. We can see we're not far enough here. So 2 things to move. We have to fix the extrusion a little bit and fix this extra piece. So let's actually do it in reverse. Fix the shell first. It's asking for bodies, but what it does is if you just pick the body, it just hollows it. Another way to do the shell is to actually pick the faces you want to remove. That's these guys. Just pressing Command to remove the preview. That looks good. Let's check how we're doing 2 steps at a time. It's better. Next, we're too far inboard, I would argue. So we should try and put the housing through the balls, or a little bit more. Let's move out 1 more nominal wall thickness here. So back into extrude. Notice when we've got offsets, when we have objects, we have offsets. Let's try NWT and see which way it goes. Oh, perfect. Let's try the same on the other side. No, that's the wrong way, so negative. There we go. Try saying okay. Look at that. Nice. So our housing is looking good there. Or at least the walls are. And we've got good gap over here. I would like to tidy this up a bit though. Right, these corners are going to be hard on the when we cast this. The contraction or the freezing of the material is going to put a lot of residual stresses into that corner. Maybe we can fix this up. The easy way is actually to do it before the shell. So let's hide our stuff and turn off our analysis and tidy this up a bit. It might be easy to actually just use a chamfer. Right click on an edge that will take a chamfer, make sure tender chain's turned on, and maybe try 10, 15. Checking. This is the inside, that's a bit close. Looks good. Better known as NWT times 2. How about 2.5? Getting a little close, it's not bad, but to be safe, let's go with 2. Back to normal view, and we can see our shells yet to happen, so shell. See both parts and have a look at the analysis. No problems over here. This looks fine. Let's just do a little check here. Anything we can grab out here to there, about 4 millimeters, that's fine for us in this size. Looks good so far. It's kind of an ugly color. Let's use a different color. Cycle. Dark purple, I don't think so. Redo, 12 o'clock. It's kind of an insipid yellow. Blue. Green. That's too much. Doing this all day here. Green it is. There we go. So that's our part. Next, so look at our sample. We need some material to hold the bearing, obviously, and right up to the ring on this guy. So let's keep an eye on our ring. Also a little chamfer here. Okay, so that means our chamfer is going to be on this side, on this orientation. So let's add something. Now, for the purists out there, and I know that's okay, we're just doing an intro here. What type of shape should this be? It's most of the time you just put a ring around here. So we're going to be filling this spot up to the inside of this, and then from here down to about there. So the temptation is to kind of do loops and follow the shape of the shaft. I'm going to do something else. If you feel this is violently opposed to your philosophy of life, that's sorry, too bad. So we're gonna have a sketch here. This is our layout. Right. Underscore. Then we're gonna edit that guy. So I'm gonna hide these two because they get in the way. Just layout right. We already have quite a lot of information here, so let's just continue. We've got enough here probably to get going without that one. So I'm going to do a slot shape. So S slot. Center to center because we have two centers. Don't go above the cut. So 100 is going to be our max. Let's see. Turn on something to give us some ideas. So we just need some material here to take some fasteners eventually. We're not going to model it in this effort because I've done it before. It takes too long. So let's just use a dimension here. Let's say 12. This gives us some room here. So maybe we need to move this guy up a couple of millimeters. Still got some room on the top. So maybe that's a good plan. One of the dilemmas is when you're doing castings, you want to pull the core out of the inside of the thing. So you want the inside core to be pull-outable, if that makes sense. So we're gonna need to, like, it's not bad form to allow some, what should we say, some way of making sure that we can get this out. We're not going to do drafts either because otherwise this video gets crazy long. So let's just do a little prototype. Let's see if we can use this on both sides. So let's have a go. Now, before we get started, one of the things that we have to be a little careful of, just hide all these sketches for a moment. I have modeled these so that the two rings on the shafts are lined up and they're on their origin here. You can see that. The problem is, sorry, wrong ring. Problem is that this is not a rational distance because of the way that it's modeled, and it's just in a slot. If we measure this, 2.02, that's perfectly fine for the bearing. That's how it comes. But for us, we'd like a rational number. 2 millimeters is quite good. If the shaft gets mounted and assembled 0.02 millimeters further in, that on both sides, that won't have any real effect on the parts or the functionality of this thing. So we're going to do a rational approach here. Rather than just going straight from the ring, we'll actually come away from the wall of the housing. So let's turn our sketches on. Sorry, and continue on. There's our shape. Now we can get rid of all this stuff and just turn on our other sketch. If we hover, we can get a little quick ghost of what's going on. So first, extrude that guy. I want to go from an object, the plane of the housing, and go up. Well, it was 2.2, so why not just go 2? But we're missing the inside. So let's rethink this. Keep it 2 for a moment. So let's instead say this is our object. And we want to go to another object. This time the wall itself again. It thinks you want to cut, no, join. And then we want to offset by 2. this should give us a small tiny gap here, which will be taken up in the assembly itself naturally. And we get it all, that's all not bad. So that's good, let's go with that. So it's looking okay, let's check the other. It's a little bit short, but that's okay, because we're mounting it in from, this is mounted on first, and then the rest of the shaft assembly is pushed in through here, so that's fine. No problem there. Now, maybe we can just do the same on the other side. Let's do another extrude. Use that sketch. This time we're going to go from one object just straight through to the next. So I'm going to use the closest ones again. So not from the profile plane, but from an object. Do another object. Not a cut, but a join. See how those go. It's good there, because that's what we picked. And it's good there, because it's not bad. It's, you know, it's fine. And we needed that chamfer. Let's do that while we're thinking about it. So we had those, had a chamfer here. Right click on it, put a chamfer in, one, say, just turn off the preview. Pick the other one. We're gonna end up with an accumulation of like smaller secondary tertiaries out here, that's okay. The other one in our guide doesn't have any chamfers. Oh, idiot, wrong one. Hold on, let's fix that. If you're doing this, maybe pick the other ones first. I'm on the wrong side. And then unselect these guys. Then you don't lose your row. Sorry about that. On the correct side. There we go. Because this is the assembling direction. It comes in from this side. Looks okay. So I'll turn off our analysis to see what's going on. Let's do a practice split. So sketch is back on. Split. Let's see if we can split it with that construction line. No. So we do need to go in here. Edit sketch. Construction X to toggle off. See if we can split this time. Split body. This guy. Tool is outline. It extends, cuts it off. Notice we have our curve starting above the split. That's good. Safer. And our gear sticking out a little bit. That's okay. Looks very exciting. How about that? And there we go. That's our beginning. Oh, no, before we continue. We do have a problem with pulling this out. There is an undercut here. Let's do another inspection on the other side. Just switch. The underside of this is not pull-outable, right? The core will get stuck on that. There's other problems here. The fillets will not go on and all that sort of stuff. We'll fix that maybe later. But for now, we can't deal with this. So let's modify our sketch one more time and add something that we can use to deal with this. The easiest way to get a tangent line is click somewhere on the line, drag, you'll see it pull around, go snap to vertical, snap to the bottom line, same on the other side. This gives us a new region. Doesn't screw up anything we've done already, but now we can do another couple of extrudes, and I'm going to do that before other stuff happens. So just keep the body showing. Sometimes it turns off from what we've been doing, and then just we can use the analysis if we want to just turn it on. Don't care about the shafts. So extrude just this piece this time, not from a profile plane but from an object, this guy, and to another object, the inside wall. join. This is good for us because if it does move, then it just moves with it. So this is object to object is always a nice way to do this. Again, extrude from an object, say this, to another object, the inside edge. We end up with a locally thicker wall. It might cause problems, but it's hopefully outweighed by having no undercut. We run all the way to the end of our part. Maybe, there we go. We can see our top housing is looking good, so we can turn the top body on and off. Now, you might have noticed we're missing this, so we might be doing a little bit of fiddling here. So we've got lots of range on the top, and we're going to put a foot on the bottom. So, but for now, I would say we're going to stop there. That's our end point of the video for now. And we'll just turn off our analysis. So that's where we're at. Next, a little bit of detailing. Make some caps for holding stuff in the top. Put some rims around as per our sample. And then maybe a last video of making holes and fasteners and all that sort of stuff. Thanks for watching. That's it for the first video. We'll see you in the next one.